Hello everyone. Today I am presenting a project on data warehouse schemas. My name is Aman Gupta and I am pursuing MCA from Vishkarma University, Pune. In this presentation, I will explain the different type of data warehouse schemas, their importance and how they are used in real world applications. Let's get started. Introduction to data warehouse. Before we dive into schemas, let's first understand what is a data warehouse. A data warehouse is a centralized system used for storing, managing, and analyzing large amount of structured data. It consolidates data from multiple sources to support business intelligence and decision making. Online transactional database, which are optimized for daily operations, data warehouse are built for analytical processing. Now that we understand data warehouse, let's explore why schemas are so important in next slide. Importance of data warehouse schemas. Organize data for efficient querying, improve performance and scalability, reducing data redundancy and improve integrity, enable business intelligence and decision makings. Schema defines the structure of how data is stored, which directly impacts query performance, data integrity, and storage efficiency. A well-designed schema helps in organizing data logically, reducing redundancy, and ensuring quick retrieval. There are different types of schemas, each with its strength and weakness. Let's start with the basic and widely used schema, the star schema in the next slide. Star schema, the simplest type of schema, consists of a central fact table connected to dimension tables. Provide fast query performance, suitable for simple high performance queries. The star schema is the simplest and most commonly used data warehouse schema. It consists of a central fact table that stores measurable data linked to multiple dimensional data. These dimensions represent descriptive attributes such as time, location, or customer detail. Because all dimensions are directly connected to the fact tables, queries run faster. However, it may lead to some data redundancy. Now, let's see how we can further normalize this schema with the Snowflake schema. In the next slide, Snowflake schema is an extension of the star schema, where dimension tables are further broken down into multiple rated tables to eliminate redundancy. These make data storage more efficient but increase the complexity of queries since more joins are required. The Snowflake schema is ideal for business that prioritize storage efficiency over query performance. Now let's move on to a more advanced schema that deals with multiple fact tables, the Galaxy schema. Galaxy schema, also called fact processing schema, multiple fact tables or dimension tables, suitable for complex business model with multiple fact sources. Also known as the fact constellation schema, the Galaxy schema contains multiple fact tables that share common dimension table. This is useful when as organizations need to analyze multiple business processes together. However, maintaining a galaxy schema is more complex and requires more computational power. Now that we have covered all three schemas, let's compare them side by side. Comparison of data warehouse schemas. Here is a quick comparison. Star schema. Simple, fast queries but may have redundancy. Snowflake schema, less redundancy but more complex queries. Galaxy schema, and a complex model but increased maintenance. Each schema has its own use case depending on business needs. To better understand how this schema work in practice, let's look at a case study. Case study, retail business. Imagine a retail company want to analyze its sales data. They implemented a star schema with a fact table containing sales transactions and dimensions table storing customer detail, product information, store locations, and time periods. This structure allows them to run quick sales performance queries, helping the company make data-driven business decisions. Now let's summarize the advantage and disadvantage of data warehouse schemas in next slide. Advantage and disadvantage of data warehouse. Advantages: efficient data organization, optimized for reporting and querying. Disadvantages: complexity increased with normalization, higher maintenance cost for large scale data. As we have seen, data warehouse schema provide structured data organization for efficient querying and reporting. Improved querying performance, optimized data storage, and support for business intelligence. Disadvantage: more complex schema require higher maintenance and technical expertise. Choosing the right schema depends on business needs. Let's conclude with some key takeaways. In conclusion, data warehouse schemas play a crucial role in structuring and optimizing data for analysis. Choosing the right schema depends on data complexity and querying needs. Star schema is best for speed, Snowflake for storage efficiency, Galaxy for complex model. Proper schema design enhance decision making and business intelligence. And in other words, the star schema is best for simple and fast queries. The snowflake schema is useful when the storage efficiency is a priority. The galaxy schema is ideal for business dealing with multiple fact tables and complex relationships. A well-structured schema leads to better data management, fast querying, performance, and improved decision making. Understanding this schema helps business select the right approach based on their data needs. With that, we conclude our decision on data warehouse schemas. That brings us to end of the presentation. Thank you for your attention.